In this video, I'm going to show you how to solve the ALEKS problem called solving a radical equation that simplifies to a linear equation, one radical basic. In this problem, you're going to be given an equality and you're going to be asked to solve for a variable inside in that equality, and the variable is going to be inside a square root term. So I'm going to start by just rewriting the problem over here. My problem is the square root of u plus 2 is equal to 9, and I just need to solve for u. So the first thing that I want to do is get rid of the square root operator. And the way that we do that, the way that we get rid of a square root operator, is by taking that whole entire expression and squaring it. And whatever I'm doing to the left-hand side of the equation, I also need to do to the right-hand side of the equation as well in order to keep things equal. So as I said, squaring a square root just gets rid of that square root term, and on the left side I have u plus 2, and on the right side I have 9 squared, which is 81. And now I just need to solve for u. I'm going to subtract 2 from each side, and that leaves me u equals 79. And the last thing that we need to do with a problem like this, whenever we're solving for something inside a square root term, or more specifically, whenever we're solving a problem by taking the square of a number, the way that we squared 9, we always need to take our solution, our potential solution, and plug it back into the original equation to make sure that it is actually valid, because there's a possibility that it might not be. So plugging 79 in for u, I get 79 plus 2 is equal to 9. That gives me the square root of 81 equals 9. That is valid. There is a possibility, like I can show you specifically an example of a time where this would not work. So what if the problem that I had gotten, instead of this being equal to 9, it was equal to -9. So over here in this part of the solution process where I took the square of both sides, I squared both sides, -9 squared would still give me 81. I would still end up with the exact same value of u, but if I plugged u into this equation, I would not end up with -9 as the result. Let's just try it. If I plug 79 in for u and see if that works, I'm going to get the square root of 81, and the square root of 81 is 9, not -9. So if that were the problem, then I would not be able to answer it, and I would need to say that there's no solution to the problem. But again, that's not exactly the problem that was given to me, so I'm just going to go ahead and get rid of that, and get rid of that, and the solution for this particular problem is 79.